if we have a rectangle with a fixed perimeter of 24 meters, that means that we only have 24 meters of fence to use. So if we have a length of 1, we can draw ourselves a little rectangle. Length of 1 over here would mean on the other side it also has to be 1. So far we've used up 2 meters of our fencing. Remember, we only have 24. So that means we only have 22 meters of fence left. So that these two sides have to both be 11. Sometimes it helps to put an extra column down here talking about the width. So if our length is 1, our width has to be 11. And to find the area, all we have to do is multiply those together. So the area would also be 11. But then if we have a length of 2, that changes a little bit. So I have 2 here and 2 there. So far we've used up 4 meters of the fencing. Remember, we only have 24, so that means there's 20 left. And if we split it evenly, each of these guys is 10. So the width this time around would be 10, and the area would be 2 times 10, or 20. And if we do it with 3, we have 3 by 3. So far we've used 6. Remember, we're starting with 24, so that means we have 18 left. So if we cut 18 in half, each of these has to be 9. And hopefully you're noticing a pattern here, that as your length increases, your width has to decrease, and then you just multiply them together. So without drawing the rest of these, I know that my width here has got to be 8, and 7, and 6, 5, 4, 3, 2, 1, and finally 0. And then I can multiply the green numbers by the length, and that will give me the area. So 4 times 8 is 32, 5 times 7 is 35, 6 times 6 is 36, and then remember it repeats. 7 times 5, it's just in a different order, so we get 35, and 32, then 27, then 20, and 11, and finally 0. So what's the largest area for rectangles with this perimeter? Well, the biggest number we have is right here, 36. What are the x-intercepts? Remember, that's when y is 0. And in this case, y is our area. So if we were to graph this, where would it be 0? When would we have 0 area? And it's going to happen twice. First one's going to happen over here if our length is 12. And then we kind of left something off here. If our length is 0, that means our width would have to be 12, and our area would also be 0 again. So our two x-intercepts are at 0, 0. Remember, this means if your length is 0, your area is 0. And then our other option is 12, 0. And again, remember, this means if your length is 12, you've used up all the fencing. Your width would have to be 0, and that's why your area is 0 again. Equation for the line of symmetry. Remember, the line of symmetry is right in between your two intercepts. So what's right in between 0 and 12? Well, it has to be 6. And remember that it's always x equals a number. If we want to come up with an equation, remember that we know area is length times width. But we don't want length and width in there. That's two variables. So if we have this fixed perimeter of, I should say 24, fixed perimeter of 24, we can work with that. Remember, that means that when we have our rectangle, if I make this side length L and that other side length L, we've already used up some of our fence. And because rectangles are symmetric, we know that this part right here has to add up to half of our total perimeter. So if our total perimeter is 24, this guy over here has to add up to 12, and so does this guy over here. If I've already used up L amount of fence on this one, that means I have 12 minus L left over. And you can think about that with numbers. Let's say this was 2. Everybody would tell me that this guy would have to be 10, because you subtracted. If I told you this guy was 4, you would subtract, and you would end up with this guy having to be 8. So you're doing that unconsciously in your head without knowing it. You're taking the total that it has to add up to, 12, and subtracting what we've already used. So now, instead of writing length times width, I'm going to write length times width, which is 12 minus L. So the area of all rectangles with this fixed perimeter are going to be length times 12 minus our length. And then we want to sketch a graph of this. So make a graph of this whole situation. We need a title, labels on the X and Y axis, and scales. So we know length has to be down here, and area has to be over here. Our area went up to 36, so let's count by fives. 15, 20, 25, 30, 35, 40. And then our length only had to go up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have a couple important features here. We found the two x-intercepts, so those can be points on here, 0 and 12. We found our line of symmetry, which is right here at 6, right in the middle. And we know our vertex, we know our highest point. We could graph all of these points up here. All of them are good points to graph. 0, 0, 111, 220, 327. But hopefully we know that this is a parabola. It's going to be symmetric on both sides. So if we have the two intercepts and graph the vertex, we can get a nice smooth curve from just this little bit of information. We know it has to start there, curve up, and come back down. And now remember, this equation, if we were to graph it like in our graphing calculator, would go on forever and ever and ever in this direction and that direction. But it doesn't make sense for our problem, so we can leave it here. And then we have to include a title. So this is areas of rectangles with a fixed perimeter of 24 meters. And that's it.